Good evening, everybody. Really good to see you all. Thank you for those of you that are here physically. It's nice to have an audience that I can actually see. And then for those of you that are online with Facebook or YouTube or whatever, appreciate you signing on, taking the time out of your evening to log on. I hope that you are able to see the slides okay. I've tried to make the text on these slides huge. So it's not only because I think you people here are short-sighted or blind, but obviously for the people online, I'm wanting them to be able to see as much of the slide as possible. Amen. Today we're in the third session, and we're going to be talking about life. Is it designed or is it created? This particular topic is a huge topic. And it's such an important topic for Christians to understand, because essentially the creation of life and evolution, or the theory of evolution, is the backbone, or the science, inverted commas, behind materialism, naturalism, atheism, and many other worldviews are relying on evolution, including religions such as Buddhism, are relying on evolution to explain the creation of life. And in my opinion, evolution is probably the greatest lie or the greatest hoax that has been fostered upon humanity since life began. And I normally play a 5-minute video where I actually show interviews with different students at different universities, asking them about where they think life came from. And it's quite amazing to just see how many people just assume that we're descended from monkeys, etc., etc. It's everywhere. So this is such a critical subject. And my purpose in sharing this evening is I really want to encourage those of you, particularly those of you that are troubled about evolution. If you believe evolution, it's very, very hard to believe the Bible. There are people that believe God used evolution, and they find no incompatibility with the Bible, theistic evolutionists. I have a real problem with that. I don't want to go into that. I do want to say that if you believe that you descended from monkeys and that life was created spontaneously from nothing, I think it's very difficult to feel that you have purpose and meaning in life. And one of the things that we'll talk about is when we talk about this particular subject, know that you have a purpose. To me, evolution robs people of a sense of uniqueness and purpose and destiny, because you're just here to breed. All right? So last week, the first week we talked about worldview, and we talked about truth and reality. And then the second week we talked about creation, Big Bang or Big God, and we really focused on reality and where does reality come from. And as you know, that evolution essentially teaches that all reality comes from nothing. A singularity that itself, nobody knows where it came from. And we talked a little bit about that. So today I want to talk about evolution, change, or design, life. And this subject that I'm dealing with now is normally a 2-3 hour lectures. I've condensed it into one lecture, and as the Lord is my witness, I had to throw away so many slides that I really wanted to show you, so many really good videos that I wanted to show you. I just don't want people to be here for too long. I may go a little bit over the hour today, but I'm really going to try and just keep it tight, because I'm conscious of the fact that people are online as well, and it's difficult to stay focused for that period of time. So what I'm going to do is, as I got to think about this particular subject, I thought about evolution. I normally take a fair amount of time to explain what evolution is, what it teaches. And it sort of occurred to me that probably most of you are pretty familiar with evolution. I mean, it's pretty much shoved in your face everywhere these days. Raise your hands if you know what evolution is about, pretty much. Right? So I don't need to waste 45 minutes explaining what evolution is. What I will do is I'm going to literally whisk through the first 10 or 15 slides, which is kind of just to give you a little refresher on evolution, but I'm not going to spend any time there. I'd rather spend my time on what I have problems with evolution. Amen? Rather than telling you what it is. Now, there's a lot of information on these slides, and you probably have noticed on the previous courses, there's just tons of stuff on slides. The reason that I'm putting so much information on slides is because I'm going to be converting all of these slide decks into PDF files for you. And in fact, I'll probably do it this week for the 3 lessons that we've had so far. It'll be put onto a website for the church, and then you guys can just simply download those. And the reason that there's so much information on the slides, because I'm not going to read from every slide and cover all of that stuff. There's just too much. But at least it's there, so that if you ever want to go back to it and look through it, the information's there for you. So I'm not intending to read every point on every slide. I'll just highlight the critical stuff. But when you finally get the PDF, it's there if you want the detail. Amen? Does that make sense? Good. All right. So I'm going to go fairly quickly then. So know that you have a purpose, life. Is it by chance or is it by design? So let's just quickly, why does evolution even matter? I mean, why are we even talking about evolution? Well, as you know, evolution is taught as fact everywhere. In fact, I've gone online and I've got quotes from different people that basically think that if you don't believe in evolution, you're a flat earther, or you might as well have a tinfoil hat on. And the theory of evolution, like the theory of gravity, is a scientific fact. Well, there's a real problem with that statement, because I can actually prove to you that gravity is real by actually making it happen. I can jump off a building. I can't show you evolution. Evolution took place supposedly billions of years ago, and it's not the same thing as gravity. One's what we call observational science, and it's one what we call historical science. It happened in the past. So there's a big difference between gravity and evolution for a start. You cannot be both sane and well-educated and disbelieve in evolution. Well, there's a problem with that statement already, Mr. Dawkins, is there are literally hundreds of thousands of scientists all around the world. And when I say scientists, I'm talking about biologists, chemists, paleontologists, archaeologists that don't believe in evolution. And in fact, I've got a website that I'll refer you to later that just where people go online that are scientists with PhDs and say, I don't believe in evolution for the following reason. So apparently you can be sane and well-educated and not believe in evolution, but there you go. The evidence is so strong that any sane, educated person has just got to believe in evolution. Well, I consider myself sane, I consider myself fairly well-educated, and I don't believe in evolution. Certainly not in the sense that Richard Dawkins intends for us to believe in evolution. Moving on. Evolution not only is taught as fact, but it's been propagated almost as evangelistically, almost as a religion. In fact, many people do regard it as a religion or a cult. The God Delusion, The End of Faith, God is Not Great by Christopher Hitchens, Science and Religion by Dennis. I mean, it's just by Daniel Bennett. There's just so many books out there. Millions of people have read Richard Dawkins' The God Delusion. I was on the train fairly recently and I saw someone reading it, and I just wanted to my heart just broke, because that book is just full of lies and errors. Moving on. Evolution has had a devastating impact on society. It really has. Darwinism has had the devastating impact on society. Ramifications reach into the deepest aspects of our life and culture. It's not really a biological theory of little significance. It is a worldview diametrically opposed to the Christian worldview. Christians, you ignore it or you compromise with it at your own peril. Evolution is at the core, as we've talked about this in worldview, of many, many evils. Communism, Nazism, racism, atheism, eugenics, abortion, euthanasia. Hitler formed his racial and social policies around the idea of survival of the fittest that was taught by Darwin's book. Stalin, the world's worst mass murderer, a friend lately said that Stalin became an atheist after reading Darwin's manifesto. Mao Zedong, China's notorious communist, is known to have regarded Darwin and his disciple Huxley as his two favorite authors. There's no doubt that evolution has had a tremendously negative effect on society. Now, I'm not saying that everybody that believes in evolution is going to turn into Mao Zedong, but I am saying that evolution gives you a framework of your worldview that allows you to do things because you don't consider life sacred in the same sense as a God-created being. There's a lot of ramifications around evolution and believing it. So quickly then, what does evolution teach? And I'm just going to literally skim through this because most of you know it. It teaches that all life arose due to a gradual change to the DNA of a species. We all got DNA. It teaches that it changes. Natural selection then preserves these changes created by genetic mutations that help an organism reproduce. These mutations and the associated traits gradually become more common among the whole group. So essentially, evolution, or the general theory of evolution, has 5 pillars. The first pillar is abiogenesis. Evolution teaches that all life spontaneously arose from non-life. All right? All life came from non-life. A lot of people don't realize that. That's what it teaches. The first cell that was ever created, that was ever came into being, essentially came from non-life. It teaches common descent, that all life ascends, not only did it come from non-life, but it comes from a single common ancestor. It teaches genetic variation, that all change is due to mutations or recombinations of genetic sequences. It teaches natural selection, that these changes due to mutations and recombinations are preserved and accumulated by survival of the fittest. Who's all familiar with survival of the fittest? Natural selection. And then lastly, it teaches speciation, that all new species on the earth, including humans, plants, trees, animals, whatever, are formed due to natural processes, generally caused by geographical isolation or boundaries. All right. Those are the 5 pillars of of evolution. All right. So what evidence is there for evolution? Now, I'm going to give you the main evidences that are produced or presented for evolution. I'm not going to try to refute them here at this point. I just need you to be aware of them because they're going to be brought up if you're ever, these are things that are commonly taught. There are quite a lot of evidences that are presented. I'm just giving you the big ticket items. Amen? You all good? All right, the first one is the top 5 evidences to support evolution. The first one is the fossil record. We've all heard of the fossil record, and evolutionists love fossils. My personal feeling is that fossils are a creationist's best friend. I don't believe the fossil record supports evolution at all, we may talk about that a bit later. But essentially, the fossil record, they talk about if you go into the fossil record, that you can see all of these various intermediate fossils, okay, or what they call transitional fossils, halfway between a bird and a dinosaur, or halfway between a fish and a mammal, etc., that you can see these things in the fossil record, and that is proof of evolution. The second one is comparative anatomy, where we can look at different species. We can look at apes, we can look at people, we can look at various animals, we can look at whales, and we can see that they have a very similar anatomy in many ways, similar bone structure. We've got the same type of DNA structure, etc. The third one that is produced is what I've called direct observation, where you can theoretically see evolution actually happening, and they normally talk about bacteria. Evolving bacteria to antibiotics, or a coronavirus that mutates to become a new strain that's immune to an antivirus drug. That's fairly relevant right now, right? And they talk about vestigial traits, they talk about bad design. All of those things are normally covered in direct observation. You can see that the back is not designed very well. Therefore, that shows that it couldn't have been done by God, because if we wouldn't get stiff backs because it would have been perfect. And The Blind Watchmaker is quite a famous book by Richard Dawkins where he discusses some of those issues. Then the fourth one is molecular homology, where they speak about genetic code, similarities between organisms. And then last one is biogeography, there they talk about the distribution of species around the earth. And those are the top 5 evidences that you'll typically see presented by evolutionists. I don't know if you're familiar with all of them, but those are the ones that you'll generally get presented with. So I'm just going to talk about each one of these very briefly. I'm not trying to convert you to evolution here, but I just need you to know what they teach. So the fossil record, they talk about transitional forms, and they have these fossils that you'll see in various museums. The most famous ones are listed there, okay? Tiktaalik, Pakicetus, etc. These you'll see in museums, particularly this particular one, where you'll see Pakicetus returned to the water and became a whale, etc., etc. And there's a lot of information around that. Tiktaalik is quite a famous fossil. It was supposed to be one of the first mammals that ever walked on the earth. Subsequently, incidentally proved false, but we won't go there. So these are the ones that you'll see. Much of this type of stuff is going around. I have, in previous lectures, gone through each one of these and showed you proof that they are not actually real fossils, that this particular Archaeopteryx is not a transitional fossil between a dinosaur and a bird. It's actually a true bird. It's got feathers, identical to modern birds, etc., etc. But I'm not going to go into all of that today right now, but I'm just letting you know these are the type of things that are presented. They talk about the sequence of fossils. They talk about the consistency of the sequence of fossils from early to recent. So in the top layers of soil, you can find mammals, and then as you go further down, you start to find, dinosaurs, and you go further down, you start to find crustaceans, and further down, you'll start to find mollusks, etc. And they talk about the sequence of the fossils as strong evidence, persuasive evidence for evolution. I'll talk a little bit about that perhaps a bit later on. The next one is comparative anatomy and embryology. Here they talk about the similarities between this anatomy of different species. And you can see here they're talking about showing you how a bird's wing is very similar to a frog, similar to a turtle's leg, a whale, a horse, and a human hand. And they're trying to demonstrate there that this has presumably just gone through various evolutions to become that, because they're quite similar. And they talk about a lot of these comparative anatomy. There's a lot of stuff around that. The other one is comparative embryology, which really compares and contrasts the embryos of different species to demonstrate how we're all related. Haeckel's famous evolutionary forms, these charts, have in fact been disproved. In fact, Haeckel actually altered these drawings. He didn't have Photoshop, but he glued different parts of animals together and took photographs of them, and it was actually subsequently proved as a big hoax. But you'll still see these in textbooks all across the world, even today, even though it's been proved to be false. All right? There's a fair amount going on around that. The next one is direct observation, and the big one that they all use is antibiotic resistance. Richard Dawkins loves talking about this. Random mutations can cause some bacteria to become resistant to certain antibiotics, such as penicillin. You'll see vestigial organs that have lost their use, and they'll talk about the appendix and in case, if you're an evolutionist, your brains, things that are no longer used. And that was a joke. It was meant to be. But okay, vestigial organs, they suggest that an organism has changed and simply doesn't need that organ anymore. Well, we all know that appendix are actually proven to be fairly useful. When I was a kid, you pretty much had your first sickness, and the first thing they did was whip your appendix out. It seemed to be the thing to do. They don't do that anymore because I've subsequently realized that the appendix, in fact, has got some valuable uses, and it's not a vestigial organ. Tonsils, when I was a kid, you pretty much whipped them out the first time you got a cough. They're not going to do that anymore because they've realized that tonsils have actually got a very valuable function, and it's a last resort. So the other one is evolutionary adaptation. And here we talk about creatures that have adapted themselves to the environment that you can see. And the famous one is, of course, the mottled moths. And you'll see lots of stuff about the mottled moths. You'll see stuff about cane toads. You'll see stuff about all of these birds, the Darwin's finches with the different shapes of the beaks on the different islands in Galapagos. All of those things fall underneath evolutionary adaptation or direct observation. The fourth one is molecular homology, and here where they start talking about our DNA and how similar our DNA is to several other creatures, which means we probably evolved from them. Who's heard the famous 99.4% similar to a monkey, right? That percentage varies on an hourly basis. I've heard from everything from 98 to 99 to, it varies. So apparently molecular similarities provide evidence for the shared ancestry of life. DNA sequence comparisons can show how different species are related. They're very selective in what they put on these charts, by the way. You've probably got about a 55% commonality with a banana. in your genetic sequences. So I'm just saying that they're pretty careful what they put here, and we'll talk a little bit about some of those. Very selective, all right? So the latest research, incidentally, has pushed this figure down to 70% now, and it's dropping. Okay, I just looked at the latest research, 70% similarity, all right, to chimps. That's a big difference, let me tell you. All right, so moving on, biogeography. Biogeography is a study of geographical distributions of biological organisms. Many geographical features provide barriers to species, allowing scientists to observe how they evolve separately. And you'll see a lot of stuff around that. Okay, let's get to the meat of this. I've spent probably a little bit too long on that. I'm sorry. I wanted to go through it quicker than I have. What problems exist for evolution? I'm going to have two sections that I'm going to cover with you now. I'm going to quickly go what problems exist for evolution, and then I'm going to focus on the real part of this lecture toward the end, which is the 5 reasons why I don't personally believe in evolution. All right, the positive side. So what problems exist for evolution? Well, firstly, let's talk about those 5 pillars that we talked about, all right? We talked about abiogenesis. The big problem with evolution, talking about life coming from non-life, is you've got to ask the question, how does life come from non-life? I mean, if your daughter came to you and said that she's pregnant and it just spontaneously happened by magic, you'd probably be fairly suspicious that she's not telling the truth, because we instinctively understand that life needs to come from life. Rocks don't suddenly turn into people. Hydrogen doesn't become living creatures. And it's a real problem for evolutionists. The second one is common descent. Where are these millions of transitional fossils? You would think that if we did in fact descend from a single-celled organism, that you would see all through the fossil record millions of instances of half dinosaurs, half birds, half mammals, half fish. You'd be seeing these everywhere as we went through all of these evolutionary stages. We just don't. Okay, there are a few here and there. Most of them have been proved to be fake, incidentally, but there's just not millions of them that there should be. There are millions of fossils, though. We find fossils everywhere, but you just don't seem to find these transitional ones halfway between two creatures. Genetic variation, the big one. How does information come from random mutations? I do a little bit of coding. I've got my son-in-law, my son and my son-in-law both do coding. Various coding with Python and other languages, and they know very well that a small mistake in their code causes the code just not to work very quickly. They're really fussy about where they put their little commas and their little parentheses and all that. It's really a critical science. Somehow, where does information, useful information, come from? From random mutations. Natural selection. How do blind processes know what to preserve? And lastly, speciation. How can small changes be extrapolated to create a brand new species with a new genome? So I'm just going to quickly look at these. Abiogenesis. Life created from non-life. For me, this is one of the big ticket items. You talk to an evolutionist and say, how does life come from non-life? The law of biogenetics, okay, of genetics says that life only comes from life. And you'll find that evolution teaches that there was a singularity. We don't know where the singularity came from. People like Stephen Hawking and that believe the singularity came from gravity. But then you've got to ask, well, where did the law of gravity come from? You know, et cetera, et cetera. But anyway, let's not worry about that. Eventually, you go through the Big Bang, through atoms, through stars, through the 92 elements, compounds, molecules, RNA, DNA, until you get your first self-replicating protocell. And apparently, this self-replicating protocell turned into all of us over billions of years. These are real problems, by the way. This is a very sophisticated piece of molecule, and this is an even more sophisticated piece of cell. We used to think cells were kind of like in Darwin's day. You looked at a cell through a microscope, you couldn't really see what it was, but it looked like a fuzzy blob of jelly with maybe a little bit of, a bit of notch and a bit of orange. That was it. Now that we understand and we're looking at these, and in previous lectures I've actually shown you some of the complexity of a cell. It is an entire massive factory in there with mechanisms for transportation, mechanisms for receiving and delivering, mechanisms for storing, mechanisms for protecting. I mean, it's just, there's a whole world going on. Incredibly complex. This doesn't just pop out of nothing. All right, moving on. The problems with biogenesis. Life from non-life has never, ever been observed. If it could happen by chance, why can't we do it today? I've got lectures that I sometimes show from some of the world's top biochemists and people that play with molecules and people that play with cells. They are not able to produce life from non-life. With all of our computers and all of our knowledge, we just can't do it. Never been observed to happen. Life from non-life violates the scientific law of biogenesis that states that life only comes from life. Biogenesis at first and biogenesis ever since is not logical. Now that statement there, life from non-life happened once at the beginning of creation or beginning of life, and it's never happened again as taught in universities today. It's not logical. Why should a biogenesis suddenly decide not to happen anymore and now we only get life from life? Life is extremely unlikely to occur by chance. And again, I could talk to you about molten pools and lava pools under the sea and hydrothermic vents and all of these things. It's extremely unlikely that life would just arise by chance in a pond somewhere. All right? Moving on. No one knows how life started. Evolution is pure conjecture. So-called science has an agenda to keep the talk of a designer out. There are many, many people today that have a real problem with a biogenesis. Where did life start from? But you start publishing papers about it, or you start talking about it, and you find yourself out of a job very quickly. And I've got interviews from scientists that I normally show around that. Today, a biogenesis at first and biogenesis ever since is taught as fact. All right, moving on. The big elephant in the room. I'm quoting here from evolutionary Professor Paul Davies, no Christian. Many investigators feel uneasy stating in public that the origin of life is a mystery. Even though behind closed doors, they admit they're baffled. It's the software of the living cell that's the real mystery, not the hardware. How did stupid atoms spontaneously write their own software? Nobody knows. The basis upon which we as scientists are relying on for the creation of life is so shaky that we must openly state the situation from what it is. It's a mystery. If you get an opportunity, I would encourage you to go onto YouTube and look up Dr. Chaim's tour. This guy is a top professor, a top biochemist in his profession, and he has got some amazing videos talking about the origin of life, how it could not have happened by chance spontaneously. Really good to have a look at some of his stuff. I know I would play some of it if I could, but it's not ideal to play it for people online on a screen here. The next one is common descent. Talks about all life from a common ancestor, right from that protocell that we saw earlier through, all the way through multicells, simple creatures, fish, pteropods, reptiles, dinosaurs, mammals, apes, all the way through to mitochondrial Eve. Incidentally, science agrees. One thing the science does agree with is that all humans descended from a single female. We call her Eve, but they call her mitochondrial Eve. Right? So there you go. I don't want to spend too much time on that. The fossil record. So where are the transitional forms? You'll see these trees everywhere in books, and they look really nice. You'll see this sort of cell at the bottom, and then all these big branches sort of going up with all these creatures, and you think you've got this beautiful tree of life. The truth of the matter is, in reality, there's just gaps everywhere. We've got this, and then we've got all these gaps here, and then we find a fossil here, but we've got no link between here, and no links here, and no link, and we just got fossils everywhere. We've got no transitional forms. The problem is you go into the fossil record, and you just find these creatures that are fully formed. You don't find them in a transitional state. Very, very interesting. Moving on, the fossil record shows the abrupt appearance and generally lacks intermediate fossils. The other question I'm asking is, why are fossils remaining unchanged for millennia? Here we've got some example of some various fossils and stuff, and I've got different worms and scallops and garfish fossils, etc., etc. The garfish pictured here is between 54 and 37 million years old. So we're talking about something that's 54 million years old, no different, 54 million year fossil to a modern version of it. Modern version, fossil. If evolution happens and things mutate and change, why over 54 million years has nothing happened here? Did evolution just decide that you're good, you're just going to stay the same? There's many, many fossils that they've found that they've assumed were extinct millions and millions of years ago, and then they're suddenly finding living versions of it. The other problem with the fossil record is that out-of-order fossils. Remember we talked about the fossils going from sort of humans, and then you would sort of get your sort of mammals, and then your fish and your dinosaurs, and going through all of the different things. There are many, many examples of mammals mixed in with dinosaurs. Now, mammals weren't supposed to have been around at that time, but we frequently find fossil mammals with fossil dinosaurs in the same strata. And I've given some examples of fossils that are completely out of sequence in the genetic record, geological record. Pollen fossils, dinosaurs, are supposed to have evolved into birds, but they found birds in the stomachs of dinosaurs, which is a little tricky. You've got dog-like mammal fossils found in the remains of dinosaurs. You've got mammal hair found in amber that was supposed to be 100 million years old. You've got grass that was found in fossilized dinosaur dung that was not supposed to have evolved until 10 million years after the dinosaurs went extinct. And there are many, many, many examples of this type of thing in the fossil record. Moving on to genetic variation. Genetic variation talks about mutations and recombinations. So all life is encoded within DNA. Are we familiar with the double helix of DNA? Most of you guys are. And you're familiar with, of course, the bases that are on the DNA sequence. And DNA is encoded with digital information, all right? Digital information in DNA. It contains a 4-digit code. When we have digital information today, we just have zeros and ones, yeah? In our digital code. Well, the digital code within DNA has got 4 digits, and this digital code actually creates flesh and blood. DNA code is transcribed and translated. All of this code is translated and transcribed to create flesh and blood. And I've got a quick little diagram there. I don't want to spend a lot of time on it, but you can basically see that you've got DNA, okay, here, that gets transcribed through RNA, mRNA, and then it gets translated through the ribosome. Acid trucks come in, creates chains of polypeptides, and these create chains of amino acids, which essentially produce your proteins. And as you know, proteins are the building blocks of everything. All your blood, all your bones, all of your flesh created from proteins. It's a really interesting thing to me to see that here you've got code that actually gives the instructions for building every single piece of protein that makes up your entire body. All of your body is encoded. Isn't that amazing? It just blows my mind. So essentially, evolution relies on the fact that this code here, during this process of being transcribed and read and translated, can occasionally make a mistake, a copying error, and cause what we call a mutation. So evolution relies on the fact that the letters of the gene sequence can get scrambled up by a mutation. These changes are caused by random mutations and recombination events. Mutations and recombinations are copying errors that occur by chance in the DNA. Now, it is true that when your DNA starts getting copied, and I'll show you a video. I don't think I've got that video, but I normally show it. But I can show you. I could show you a video of a DNA getting copied, and occasionally errors do occur. The interesting thing is that, for example, one letter error in a sequence can cause some serious issues with the protein that comes out of that. So a mutation occurs when an incorrect letter is transcribed, okay, resulting in a change in the protein sequence. And so what I can show here is the first thing I want you to understand is that these mutations have to be beneficial. Nearly every mutation that happens, virtually without exception, is a bad mutation. We all have heard of cancer. We all heard of all of these horrible diseases that happen when your DNA doesn't read the way that it's meant to read. 99.9% of the time, when there is a mutation, it is a bad thing. You do not want your DNA to have a copying error. Okay? Evolution relies on mutations and recombinations that are beneficial to the organism. If it's not beneficial, that organism is not going to become selected by natural selection, and it's just going to die. All right? Mutations almost always result in a loss of functionality. Sickle cell anemia is caused by one single letter, okay, out of 1,632 letters. 1,632 letters, one letter wrong, and you get sickle cell anemia. The cystic fibrosis is caused by one letter incorrect out of a sequence of 4,440 letters. One letter, you get cystic fibrosis. Not nice. Evolutionists will tell you, there are plenty of examples of beneficial mutations, and the ones they will always quote will be things like sickle cell anemia. If you've got sickle cell anemia problem, okay, that's a normal cell, that's a sickle cell anemia being mutated. Okay, because of the mutation is in fact it's one letter out of the 1,632. You're going to end up with that cell instead of that, and they're going to say, yeah, that's really cool. That's a great example of a mutation that's positive because you can't get malaria. All right. Well, malaria is fussy. It doesn't like those because it can't work in those. It can work in those. So all of a sudden, it's a beneficial mutation. Well, maybe if you live in a malaria-infected part of the world, maybe if you've got sickle cell anemia, it is beneficial. Forget the fact that your kidneys are probably bleeding and your liver's probably not working properly and all the other side effects that come from sickle cell anemia. I would hardly call that a beneficial mutation. And there's numerous examples of so-called beneficial mutations that aren't actually beneficial except in a certain circumstance and possibly a certain geographical location for a certain community. But as a general, definitely not. You don't want your DNA mutated. Mutations generally result in a loss of functionality, progeria, a bubble boy syndrome, deformities. Mutations are caused by insertions, deletions, and duplications in DNA sequences. Like rust eating away the steel in the bridge, mutations are eating away our genomes, and there's nothing we can do to stop them. Mutations are generally never beneficial. In fact, okay, so moving on quickly, not only does an evolution need mutations to be beneficial, but it needs mutations to generate new information. If you're going to change something from a frog into a person, or from a dinosaur or a monkey into a man, you can probably understand that there is a huge amount of information required to change that into that. Amen? We all agree with that? As similar as you might think you are to a chimpanzee, there's still a big difference between you and a chimpanzee, and a lot of information has to happen to tell your DNA to make that instead of that. Evolution relies on random mutations and recombinations that must create vast amounts of new information. Mutations can rearrange existing information, but they cannot create new productive information required to create an entirely new genome. It just can't happen. Do you know how many mutations would be required to convert you from a fish into a person? We're talking about hundreds of thousands of millions of mutations that would have to happen. But each one of those mutations would have to be a beneficial mutation, and each mutation that happened after this mutation would have to be beneficial to this one. They would all have to be beneficial to one another in order for you to convert. It's a real problem, and we call it the Information Enigma. All right. A new species requires a lot of genetic information to be created for brand new functions. Experience tells us that information requires intelligence to create it. Why is it? Why is it that I can hold this phone to you and say, this just happened to evolve out of this mouse. I left it on the shelf for a few years, and this is what happened. We know that this was created by intelligence. You can very quickly see and understand that it requires intelligence, because not only is this showing all the features of design, but it's got code in it, and it works. We understand that coding requires intelligence. Experience tells us that any information requires intelligence to create it. Interpreting information requires an understanding of its rules. Let me explain what I mean by that. I can put 4 letters on the word, on the board. G-O-D. God. All right? But you can move those letters around, and you would probably end up with dog or a totally meaningless word. The information, the letters themselves, don't tell you anything until you understand the rules behind English and syntax and the way that letters should be arranged. Agreed? So I could put a whole bunch of letters on the board here in Chinese and ask you guys, does this give you information? And you would have to say, no, I'm getting no information out of that, because you don't understand the rules behind the language, Mandarin, right? You need to understand the rules behind the language. And so with DNA code, all the information that's built into DNA, you've still got to understand the rules behind that information. How do they come into being? And then, of course, useful information is not created by random changes. We know that. My son's a coder. I tell him to just create, I want you to create some Windows 11 for me. Go for it. And he can start throwing letters together. You can put 1,000 monkeys on 1,000 typewriters if you want. You can have them trying to type Shakespeare for 1,000,000 years. You'll never get it. They actually did that. They took 33 monkeys, put them with a bunch of typewriters, left them for 2 weeks typing. Do you know that they didn't get one word? There was a lot of poo, incidentally, on the typewriters, but not one word. So new species, experience tells us that useful information is not created by random changes. No existing formal language can tolerate random changes in its simple sequence, which expresses sentences, as doing so destroys its meaning. And that's just common sense. Moving on quickly then, random chance mutations generate gibberish, not useful information. How anyone can believe that random mutations create information is beyond me. I'm going to talk about quickly, to ram this home, is not only do you have the information paradox, how does information come from random changes and the rules behind that information? But we talk about another problem when we talk about mutations creating information, and it's called the combinatorial problem, all right? This problem is quite an interesting one. Here we've got a lock with 4 digits on it, a bicycle lock. Yeah, we've all seen these locks. They've got here 1 to 10, or 1 to 9, I think it is, 0 and through to 9. So there's 10 combinations on each of these locks. So you've got a possible options to unlock this lock of 10 times 10 times 10 times 10, right? So that's 10,000 combinations that you would have to do in order to open this lock. Yep. We all good with that? So the combinatorial problem is the possible ways that a set of objects can be combined. Random changes to digital code degrade information in any section of the digital code. Now, if we have a look here, there are vastly more ways to arrange characters in a way that will produce gibberish than will produce function or meaning. A lock with 4 dials marked with numbers 0 to 9 has 10,000 possible combinations to unlock it. All right? A lock with 10 dials, if we had 10 dials on here, you would have 10 billion possible combinations to open a lock with 10 of these dials. So, what is the probability of relying on random mutations to create a DNA sequence for a construction of a brand new protein? Now, proteins are made up, as you've probably remember from our diagram before, of amino acids. And most proteins contain thousands of amino acids to construct the protein. Only 21 of those amino acids are usable, by the way, of all the different amino acids, but we won't go into that. So we're going to take a small little protein of 150 amino acids. That's a very small small example. So essentially, we've got 150 dials on our lock here. The short protein made up of 150 amino acids long would require 10 to the 195 power of other amino acid arrangements of that length. How many of these combinations of this 10 to the 195 would result in a functional protein? So we've said that there are 10 to the 195 power of combinations. What we're going to ask is how many of those combinations would actually result in the lock actually being opened, would open the lock. Now, they used to think that, well, there's a lot of combinations there, so science used to reason that most of those combinations would probably create a functional protein, obviously. Science has now investigated further and found out that it's not the case. The latest research has shown that there is only one correct sequence for a protein out of every 10 to the 77th power sequences. That, in fact, means that it's equivalent to searching for one correct sequence on a lock with 77 dials. All right? In 3.5 billion years, and if you're going to, let's assume that life has existed for that long, a single functioning protein fold via mutation selection would only have time in 3.5 billion years to search 10 trillionth of the total number of combinations required to produce one single protein. And you are made up of thousands of proteins. There just isn't enough time in evolution for random chance mutations to go through that many combinations and to create a single protein, never mind thousands of them. The probability problem. There are no known types of information-gaining mutations necessary for large-scale evolutionary processes. All types of gain-of-function mutations put in the light of the long-term needs of upward evolutionary progress are exceptions to what is needed, because every example that I've seen involves something breaking. Can a mutation create the kind of information needed to produce a genome? Absolutely not. I've got an interesting, is Bluetooth on at the moment? This is Richard Dawkins, who's very famous, of course, for his books and that. He gets asked by a reporter, where does information come from? It's quite interesting to see his response.
Can you give an example of a genetic mutation or an evolutionary process which can be seen to increase the information in the genome?
Can you just stop? I think.
Yeah, it's a real problem. All right. Natural selection. I want to talk quickly about natural selection, and then we'll move on to the part of the speech I want to get to. Natural selection is not evolution, all right? Natural selection just takes something that's got mutated and makes a decision whether, in fact, it wants to keep it or not, preserve it or not. So a good example of it would be, this is not natural selection, this is unnatural selection, but selective breeding of dogs, all right? Who's seen how you can take a dog and you can breed it over several generations to produce one of these little fluffy little jobs that you pop in your handbag if you're a girl, or one of these big brute dominant things? They're both dogs, right? But by through selective breeding, you can produce one of those or you can produce one of those. They're still dogs, but they're radically different types of dogs. Little Chihuahuas, Great Dane, all right? And that's done through unnatural selection. What we've done is, instead of allowing Mother Nature to make the decision what to keep and what not to keep based on whether they can survive or not, we're actually interfering and saying, we want a cute little pooch that can go in a bag, so we're going to pick the smallest babies from the Great Dane, and then we're going to wait till they have babies, and then we're going to pick the smallest ones of those until eventually we get what we want. All right? That's unnatural selection. Now, natural selection in nature assumes the same thing. Something's going to mutate. Let's assume that a dog gets born with a mutation that causes it to go big and hairy and fluffy, where all of his brothers and sisters are like got short fur. So we got this dog with fluffy fur. Suddenly there's a cold spell, and the temperatures drop to minus 10 degrees, and virtually all the dogs die out except for the ones with the big fluffy fur. And of course they have babies which are going to have fluffy fur, and so you end up with lots of dogs with fluffy fur and very few dogs, if any, with no fur. And you've seen natural selection, survival of the fittest. All natural selection does is preserves beneficial mutations, okay? Unfortunately, sometimes it also preserves non-beneficial mutations, I suspect. But anyway, so it's not evolution. I don't want to spend a lot of time, but natural selection cannot create anything. Okay, it is a selective process, not a creative process. And it can only act upon life that already exists. If there is no life before life sprang out on the earth, how did natural selection choose something to decide to, it needs life to act on? So how did non-life become life through natural selection? There was nothing to select, right? Moving on, natural selection is not evolution. It only preserves mutation, removal, or rearrangement of genes. It has no foresight. So natural selection can't say, you know what, I'm going to make a human. Now, I've got this fish here. Now, what do I need to do to preserve to get that human? I tell you what, I need to preserve these flippers here because they could eventually become a hand. And I'm going to preserve this because this could actually become a leg. It can't do that. It has no ability to foresight. It's got no intelligence. And so it doesn't know what to preserve and what not to preserve, other than the fact that this is presumably beneficial. It has no directed outcome. It's unlikely to preserve countless, because we're not talking about one or two mutations. We're talking about thousands of changes over time for macro changes to occur. It explains survival of the fittest, but not the arrival of the fittest. Evolution demands that massive amounts of new information come over time. The above examples of information that has been lost or corrupted. This can scarcely said to support evolution. Floppy ear syndrome. These changes in dogs and that. This is natural selection at work. This is not evolution, all right? This is simply selective breeding. Moving on very quickly then, speciation, a new genome for micro changes, and there's a whole lot of things that I could talk about here, but we don't see this. One would kind of expect to see some weird half creatures coming around, you know? We've got these creatures here that are combinations, but these are all species that can interbreed with one another. You'd be very hard-pressed to say that they're different species at all right? So when you talk about ligers, wolfins, zorses, and ligers, these are not new kinds, okay? These are animals that are able to interbreed with one another, but you don't see these. Trust me, if I saw one of those strolling across my lawn, I would know about it, all right? There's a real problem with some of the stuff that they talk about, okay? Just in the last 5 or 10 minutes, I just want to talk about my personal top favorites for why I don't believe in evolution and why I believe that we're designed and not created, okay? Now, I know I've gone really quickly, and I haven't done this justice, but even if I've just given you some things to think about today, that will be good. My top 5 for believing in design, all right? Understand, first of all, that planning and design are really crucial to positive outcomes, okay? We see some examples there of people that didn't plan or design particularly well, and we all know what happens when you don't plan. And we've already said that natural selection has got no foresight, so one would expect a lot of this type of thing to be happening without a plan, right? The plan, incidentally, in your DNA is an amazing one. Okay, so first of all, good planning is crucial. I'd love to do that, incidentally, as a joke in a men's loo sometime. So here we go. Oh, it's the top 4 reasons. I probably cut one out because I'm trying to keep it short. The top 4 reasons why I believe in intelligent design rather than chance. And these 4, amongst others, have kept me very confident of my faith. I tell you, some of these things have really held me in good stead when I've had to listen to some of the stuff that's in the news, or reading stuff in scientific papers, or listening to Richard Dawkins, or watching David Attenborough on his Earth things. All of these things, these have stood me in good stead. All right. Number one, DNA contains real, actual digital code. I'm not pretending it. It's actual digital code. Do you know that they can store movies on DNA and play them back off DNA? Did you know they can do that? They've actually stored movies in your DNA, multiplied the DNA, have it grow, and then they've got thousands and millions of copies of the movie. How cool is that for duplication? Talk about copyright violation. And then extract it out again. They can do it. It contains real, actual instructions for making you. All right? So we see digital code, design, scene, and information. Your DNA contains information. Specified complexity, we see design and purpose. Irreducible complexity, design and interdependency. And biomimicry, design and functionality. And I just want to touch quickly in the last few minutes on each one of these. These are the bedrock of a lot of the stuff that has helped me. DNA code contains actual digital information. Information does not happen by accident. It requires rules behind the information. It requires an understanding of syntax, of language, of pausing, of starting, of stopping. It understands, it has to have meaning. It has to have a lot of things. Even the English language has to have a whole lot of rules behind it before it means anything. I can take all 26, how many letters have we got in the alphabet? 26? I can take all 26 letters of our alphabet and start throwing them around and ask you if you've got information. Have you got information? You've got data, you've got stuff, but you don't have information. In order for it to have information, I have to apply rules to that data and start forming sentences and structure before, and then you need to understand those rules to interpret it. How is DNA interpreting its own information? Who wrote the rules? It's quite interesting to me that SETI, it's a search for extraterrestrial life, has been going for years and years and years now. Millions of dollars have been poured into SETI. They've been scanning the universe for years and years and years, looking for a non-modulated digital signal. Okay? So they're looking for a signal in space. They're listening for something that's going to be repetitive and that is going to be, in a sense, understood as information. All right? So it's looking for information. It's looking for non-random modulated code. Okay? That would indicate that it's not just coming from a pulsar or some weird planet. It's actually intelligence. They're looking for non-random modulated code. That's how you can recognize intelligence behind a radio signal. Okay? We've got all of these years that we've been looking for this non-random modulated code in space. Trust me, if we got we would be calling every newspaper in the world saying we've just discovered aliens, calling SOS, you know? We would be so excited about it. Nothing. But you turn your telescopes inward and look inside your own bodies, and you see gigabytes, millions and millions and millions of detailed, concentrated code that's capable of building a person. And somehow we don't think that's intelligent life that created that. Is that not a bit of a weird one? All right? And so there's a statement there that basically says that. DNA, all right. Code into flesh and blood. Do you know that your DNA is 2 millionths of a millimeter thick? That's pretty small. I don't know if you realize that's really tiny, all right? It's able to repair itself. Can you imagine if you designed a car today that could repair itself? And you said it happened by accident? People would laugh at you, right? Imagine if my iPhone could repair itself. It contains information. It retains information for over 100,000 years. Scientists are trying to use DNA to store information because it's so longevity in its storage capacity. It minimizes the effect of copying errors. It has a replication precision of 1 error per 10 billion letters. Show me a typist in the world that can equal that one. DNA codes for over 100 trillion messages per second. Now that's what you call internet bandwidth. It has 2.75 meters. How long is 2.75 meters? It's probably from the end of the table to here, right? That's a fairly long length. That's how long DNA is. It's coiled into every one of your body's 100 trillion cells. That is an amazing feat. You try to stuff that in. I mean, I'm trying to pack up. I take the brand new stuff that I brought from the hardware store. I take it out and it's not working. I try and pack it back in the box. It ain't going. No matter what I do, I don't know how they fitted that in that box. Somehow DNA's got 2.75 meters of DNA coiled in your 100 trillion cells, 1.8 zettabytes of data in 1 gram of DNA, equal to all the information in the entire world. And this all just happened by accident. Specified complexity is my next big one, design and purpose. Specified complexity is displayed by any object or event that matches a discernible pattern. I don't want to talk too much about it. I just want to talk about William Dembski's stuff. You guys look at this. Which one of these two would you say has been created by intelligence? We recognize it instinctively that is probably created by random probability or chance. This has been done deliberately. If I told you that the wind and the sun and the rain did that, you'd probably be looking at me saying, I don't think so. We recognize instinctively something that's been created because of patterns and order. We know that this was designed, this was not. All right? Same thing here. We recognize that this is random, as interesting as it might be, but we know that this is not. This is because we understand patterns and order and association. We recognize that this is instinctively created by intelligence. So why is it then that we can look at the trillions and trillions of detailed instructions in our DNA, where one letter can cause cystic fibrosis out of place, and somehow we think it just happened by Mother Nature? Random mutations don't produce information. And this here is information and design. So I want to just show you something that I think is very interesting. It's one thing to say that we understand that this was designed because we can see that intelligence created it, it's got code in it and that. How about something like this? You recognize this diagram here? Instinctively is a cave drawing of a horse. And if somebody told you that this was created by Mother Nature, we probably would say, I don't think so. We recognize that the probability of that being created by Mother Nature is pretty slim because it's clearly recognizable as a horse. We recognize the patterns, we recognize the order, and we recognize association. Okay? The same is true of this drawing here of a spider, of a leaf, of an ant, and of a fly. All of these are clearly recognizable as probably being drawn by intelligence, okay? Unlikely that any of these would be formed, these drawings would be formed by Mother Nature, by pure chance, because we recognize them again by their pattern, by their order, and by association. So the interesting thing here is that if we have a look at this moth here, this fly, it's actually been replicated purely by chance on the wings of the Macrochelix Maya moth. So here not only do we have an example of a moth that supposedly evolved from something else, but here we have detailed drawings that have evolved on the wings of the moth, okay, to replicate. There's the actual real fly there that they replicate. There's one being replicated on the wings of the moth as a protection mechanism. The patterning mimics two flies on the wings feeding on bird poop. Now you tell me how a drawing that detailed, that mimics, how does random mutations produce artwork on the wings of a moth? It beggars the imagination. I didn't draw these, by the way. These are actual photographs. Okay, there's nothing doctored here. This is not a Photoshop special. You can go on Google and Google it yourself. All right? The ant, okay? Located on the wings, of the fruit fly, okay? These are actually not, these are not tattoos. These are genetically coded into the coding of the wing. All right? How does mutations do that? Can you imagine a mutation saying, I'm just going to call myself, I'm going to go into a black dot instead of being clear. Then another mutation says, you know what, I'm also going to go into a black dot instead of being clear. And we all happen to do that and actually form a picture. What are the chances of that happening? Moving on. The Lygodium spider moth. All right, there we see the moth that actually has got encoded onto its wings the legs and the body of the spider, and in fact, it assumes this position so that it looks exactly like a spider when it bends down. Amazing, isn't it? By chance, random chance. Can you imagine if I produced a picture of Jesus right here and I said, look what the wind and the sun did. I just left it overnight in the, I mean, we just know that this is design. All right? Random mutations can't be doing this. I've got the Master of Disguise. That looks just like a leaf, does it not? In fact, this is genetically encoded onto the wings of living creatures and is, in fact, this is the Europea meticulondia moth. I'm looking at some of the comments on the forum. The one guy says, I know I'm looking at a moth, but my brain won't let me think I'm looking at a moth. How did such elaborate mimicry evolve? It's like it was painted by a Renaissance master. I am certifiably overwhelmed by this. It's got drop shadows. It's got colors. It's even got veins. I just cannot believe my eyes. And I normally play a video of one of these moths actually curling up and making itself look like a leaf. Isn't that amazing? The next one I want to talk about is irreducible complexity, and I'm going to be another 5 minutes. Thank you for your patience. You guys online, thank you for your patience. I hope you can see this. I'm trying to go as quickly as I can. Irreducible complexity. Some things, in order to do what they do, have to have a minimum number of components. Here's a mouse. In order for this mouse to do what it does, it has to have this wheel, it has to have a body, and it has to have this little sensor at the bottom, presumably, and it has to have these buttons that click. If I took any one of these away, what would happen to this mouse? It would not achieve the function that I needed to achieve. And the famous one that we talk about is generally the mouse trap. That in order for a mouse trap to actually do what it needs to do, it needs to have a trigger, it needs to have bait, it needs to have a spring, a hammer, a catch, a holding bar, and a base. You can put other stuff on top of this. You could put a I don't know, a fancy pattern on it. You could put it on a little stand. You could do a few other bits and pieces to it. They wouldn't be needed. You could take those away. But if you started getting to the place where you started taking too much away, it would no longer be effective at catching mice. And this is what we call irreducible complexity. Now, what we're trying to say is complicated systems that have to perform a function cannot evolve bit by bit, because what happens is that until everything is there, it can't perform its function. A mousetrap, let's assume this could evolve. If just the spring evolved, would it have been any use to you as a mousetrap? What happens if the bait was there and a trigger was there, but there was no spring, no base, and no holding bar? It wouldn't work. In order for the mousetrap to be a mousetrap and to perform the function it performs, everything that's there has to be there at the same time and has to be connected together in the correct way. Now, that's true with many, many parts of your body, many, many complex systems like DNA, your cells, your eye. Bits and pieces of your body do not evolve separately and then manage to come together and form a working component. They all have to be there at the same time and relate to one another at the same time in order to perform the function. Does that make sense? You understand what I'm saying here? So it's really, really difficult for evolutionists to explain how something like a cell can come into being, because you need about 50 different parts to be there simultaneously, all working in harmony and symbiosis together in order to achieve the outcome. Take any part of it away, and the whole thing becomes useless. All right. So this trap, if the spring didn't evolve along with everything else, wasted time. You just wasted 10 billion years of evolving into a mousetrap. Even if the spring did evolve, but it didn't attach itself in the right place, it still would be useless, right? One of the things I just want to quick show you is a quick little video here. This is an example of what we call ATP synthase. It's a very short video. ATP is in every single cell in your body, and it's the thing that gives you energy. It's like the little batteries in every single cell of your body, trillions and trillions of them. This little battery is actually a motor that generates energy. I want you to have a look at this quick video and think to yourself, how did this thing evolve by accident? Because you'll see irreducible complexity shown here. Great website, by the way.
This animated sequence shows the ATP synthase enzyme in operation. The animation is based on an incredible series of scientific discoveries. Only the colors show artistic license. ATP, or adenosine triphosphate, is the energy currency of the cell. ATP is produced by a tiny molecular rotary motor, rotating at up to 7,000 RPM. These are so small that 100,000 would fit side by side in a millimeter. A current of protons drives the motor, unlike man-made electric motors which use electrons. This portion of the enzyme is where adenosine diphosphate is combined with a phosphate ion in the presence of a catalyst to produce ATP, which is then released, making way for the next cycle. A top view of the enzyme shows the sequential operation. Almost every biochemical process in your body requires ATP. Such a nanomachine exhibits all the characteristics of super-intelligent design. ATP is vital for life, and many of these motors were needed before the first living cell could exist. An evolutionary impossibility.
All right, the last one and I'm going to talk about of the four is biomimicry. Biomimicry is design and functionality. This is a quote by Janine Benyus, co-founder of the Biomimicry Institute. Biomimicry is the innovation inspired by nature. Engineers, architects, and other innovators are nature's apprentices. They are driven by the question, what if every time I started to invent something I asked, how would nature solve this? It seems very strange to me that highly intelligent, so-called evolved creatures like ourselves need to look at Mother Nature that evolved something by accident, through random mutations by chance, to work out how to do stuff properly. All right? Companies seeking breakthrough products tend to look to Mother Nature for inspiration. Giraffe's neck has inspired astronaut suits, okay? In the 1980s, psychologist Alan Huggins and his colleagues at NASA noticed that shortly after birth, the blood vessels in giraffes' legs quickly thicken, enabling them to walk within the first hour outside the womb. This discovery helped them improve the effectiveness of an invention known as lower body negative pressure device. Essentially what it means is that they were working out how can a giraffe put its head down in water and then lift it all the way up like that and not faint. You would expect that all of the blood would be rushing from the head when it went down and then all the way back down the neck, and the thing would just fall over. I mean, sometimes if I get up too quickly, I nearly fall over. With a giraffe, and they worked out that it's got valves and things in its neck that close off and maintain the pressure and stop the blood rushing back down. They're using an astronaut suits to solve the problem. Woodpeckers, they were wondering how on earth does a woodpecker not absolutely destroy its brain when it's smashing its head into trees. And they've actually done a whole lot of studies and worked out the way that the head and the brain are protected and that, and they're using it for crash helmets, okay? Shark skin-inspired swimsuits, they actually had to ban them in the Olympics because they were so effective at shaving off time in swimmers. Biomimicry, using nature as an R&D laboratory. Butterfly wings, nature's rainbows by peacock spiders. And the list goes on and on and on and on. I have literally got tons and tons of examples, and I could give you 50 easily of examples of where we are looking to Mother Nature to try and work out how to do things better. Everything from optics to designing spacesuits, to designing faster vehicles, to designing aeroplanes, it's all there. Transparent glass, stronger than steel materials, all of those things, we look to Mother Nature. It's fairly obvious that if intelligence is looking to this for an example, you would assume that that intelligence is greater than our own, right? And so ultimately, evolution is just monkey business. Ultimately, the Darwinian theory of evolution is no more or less the great cosmogenic myth of the 20th century. In Grimm's, you kiss a frog, and in 2 seconds it becomes a prince. In evolution, you kiss a frog, and in 2 million years it becomes a prince. Both are fairy tales. All right. If you've got questions, I'm happy to answer them. You can send them to that particular address of Gmail. I'm happy to do that for you. And just ending then from the Psalms, you formed my inward parts. You covered me in my mother's womb, and I will praise you, because I'm fearfully and wonderfully made. My frame was not hidden from you. When I was made in secret, I'm skillfully wrought. Every one of us here, both physically and online, God created you. You did not evolve from a single-celled organism by chance. You have a reason, you have a purpose, and you have a destiny. And I pray that this encourages you. And if you've got any questions, I'm always happy to answer them. I had to just go through this fairly quickly. I hope I did it some type of justice, even if I managed to get you thinking a little bit. Thank you for your time and your effort.